Okay, so yesterday I had let off on the exponential brightness equation where E equals X. So where we left off yesterday, you know what? I'm gonna delete that. Okay, Wolfram alpha's up, and the equation from yesterday was Y equals 255 times E to the negative X over 10, where X is a variable and E is an exponent. Um, or is it? Oh, it's X. Well, not really. So I had from, okay, well, all of this is pretty much useless. Should have stayed with that. Anyway, from Y equals 0 to Y equals 40. Okay. I don't know when I would use this E, but oh well, moving on. Nope, save as. So today we're going to work on triangle brightness. And I have just the idea for what I want to do, and I will draw it. So we have a graph, and it's gonna have to start from 0. Oh, here's 255, 0. So what sort of increments do we want to do? We want to finish everything, let's say, in 8 seconds. 8, 4, 6, 2, 1, 3, 5, 7. Okay, that's pretty evenly spaced. 255. Now, I want to do something like this. Dun, 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 dun. So whatever these equations would be, the slope that we chose can be estimated. Doesn't have to be an exact science. So what would you say this one is? 1 to 2, maybe 1.3. And then what might that point, that point, that point, that point? I think those should be the same height, just to reverse it. Okay, that. Okay, so we really only need to know what these are, and then on the way back, we just need to inverse it. Okay, so this 1 to 1.3. This could be 1.8. This could be maybe 2.9. This goes up to 3.2 perhaps. Could be a little bit less, 1.5.4. Okay. So now I need here. So 255, 127.5. I'm gonna need math for this. Let's say there is 1, 2, 1, 2. Let's do that. 42.5 plus 42.5. 170 to 12.5. Okay. So at time x equals 0, y equals 255, or brightness. At x equals 1.3, y equals 138. When x equals, what is this? We said about 1.8. Y equals 200. 2.9 and 100. 3.15, maybe 132. Yeah. And 4 is at 42 point, well, I'll say 40, round down. So these are the xy coordinates for each of them. Since it's just going to be linear and it's not going to be a quadratic formula, this will be much easier than what's going to come next. Anyway, since this is linear, we just do the slope of a line, m. M equals y2 minus y1 over x2 minus x1. So how do I do this? Okay, whatever. 1, 2, whoops, 1, 1, 2, 2, 3, 3. Pretend this is 4, 4, 5, 5, 6, 6. Yeah, pretend there's an x here. I'm not going to write that multiple times. Y2 minus y1 over 1.3 minus 0. And that's about minus 90. So this is y3 over x3 minus x2, 0.5. 124. 100 minus 200 over, what was that, 1.1, negative 90.91. I might as well just say whatever, 90.91. 132 minus 100 over 3.25. 128. 40 minus 132 divided by 0.85 minus 108.24. Sure. Okay. to clarify on what the numbers I put are. So here is the graph. Okay, whatever. So here is the graph. So it's going to go from 255 down, then up, then down, then up, then down, then up. And we're going to stop at 4 because I'm going to say that the positions and heights are reflective across the x equals 4. So this should be the same distance from 4 as this is. This should be the same distance from 4 as this is. This should be the same distance from 4 as this is. In the x direction, of course. Well, in the x and y direction, actually, for all of them. Okay. And so these are the approximate x and y values. At x equals 0, y equals 255. At x equals 1.3, give or take, eyeballing it from a freehand drawing. 1.3, 138, seems about there, and so on and so forth. You can pause the video here if you need. And then I did slope of a line. I get lazy further on, so the math format follows this. y2 minus y1, you know what? You get it. And label this x1, 2, 3, 4, 5, 6, because these are the individual x's on the axis, and the y is the corresponding y with those x's. Then you take m equals y2, or yn plus 1, subtracted from y1. You know what? Here's the equation in more mathematical terms. Yn plus 1 minus yn over xn plus 1 minus xn. And this means if n is the position number, for instance, x1, second x, x2, third x, x3. Let's say you choose the third one, x3, or n equals 3. So it'd be like 3 plus 1 minus y, 3 over x, 3 plus 1 minus x, 3. And so that simplifies, it should be clear that's an x, that should simplify to, if we substitute 3 into the equation, 3 plus 1, 3, and similar 3 plus 1 and 3. So simplifying those numbers further, 4 minus y, 3 over x, 4 minus x, 3. So you just take the fourth, let's move this just a little bit. So then what you would just do is take the y4 value minus the y3 value, just similar to y2 minus y1. That's just a more scientific version of it. And so, yeah, these are the m values. So, Okay, so I guess we're just going to try and replicate this into the program. Okay, brightness, how are we going to do this? So let's just say x to normalize what it is. X, and x. Well, this whole equation is actually off. So the first equation, y equals mx, we're going to start at 255 minus the m, which is 90, times x. Okay. This is actually a plus sign. That way, actually, and from 0 to 90. So you know what? Why would we do it this way? If this is the slope of the line, y equals mx plus b. This should be pretty simple. I don't know why I'm having trouble. Y equals mx plus b. Okay. This sucks. Okay. So I guess I'm not done yet. Okay, y equals, I don't know why I'm writing it again. Mx plus b. So in this equation, if y equals 255, that means b equals 255. That means in the equation y equals m minus 90x plus 255, because b equals 255. And I mean, if x equals 0, then that means m is just going to be 0 anyway. Okay, and this goes from 0 to 1.3 seconds. So at x equals 1.3, it should (90 times 1.3 times -1 plus 255. Okay, and it drops down to 138. Okay. And that is the equation that I have. And it's because x should go to 1300, because that is in milliseconds. We wrote the graph in terms of seconds, but the program takes it in terms of milliseconds, so that's why it's 1300. Okay, and so it does that, and it's going to do that for, I don't know. You know what? That controls the speed somehow, so let me figure that out. Okay, so let's see. 005. Whoops, shouldn't have done that. 006. Gonna have to delete damn, gonna have to do it now. Okay. Okay. What? Exponential decay formula. So then what? No. Yeah, this should be. That's what it is. I think this needs to be a double rather than an integer. Nope, not entirely. What if we change that to 100? Okay, this still goes by pretty quick. If x increases linearly, I guess the delay should be, what, a second? Well, I guess technically 1300, right? Or, no, 1.3 seconds. but it's not exactly linear. Um, 4, it just 10, 23. Yeah, shouldn't it be less than or equal to 1300? What happens if I put greater than? X equals 0 to x equals, x is, no, it's got to be less than or equal to 1300. It's not going to be equal to 1300. X plus plus. That's just minus 90x. What's the issue here? 0. Um, oh, 1300. Okay, hold on. If it's going to be, if it's not going to be 1.3, if it's going to be 1300, if it's going to be 1300, then what is that equation? 138 minus 255 divided by 1300. 0.09. Okay, so everything needs to divide by 1,000. 2, 3. 1, 2, 3. 2, 2, 3. Point 0. 0.09. 1, 2, 3. 1, 2, 3. Okay. That means this one is 0.0 minus 0.09. Okay. So minus 0.09 times x. That way, when x equals 1300, let's zoom this out. That way, when x equals 1300 times minus 0.09 plus 255, 138. Okay. Now, how's that math? Yep. Okay, the question there is going to be the delay. Let's go 5, not 50. Let's do x equals, you know what, we're going to do it that way, and then x equals x plus, plus 5. 5, yeah, sure. Okay, see, this is the problem with using multiply everything by 0.8. See, because it's way too bright to start with, and then to get from 255 to 138, it's not a lot of dimming factor. It does dim, but not by a lot. So how do I want to do this? I mean, the slope would have to decrease even further. but I'd have to, you know what, I don't know what's gonna happen. So let's continue with the rest of the equations. One, two, three, four. There's going to be, goodness, 1, 2, 3, 4, 5. I think 9. I think a total of, I think there's going to be a total of 9 if we're going to flip it the other way. Okay, but let's just focus on these. Y equals mx plus b. Where are we? Y equals mx plus b. So if y equals, what do we give y? 138. Y equals 138. And m equals 0.124 x plus b, and x is equal to 1.3 when y is 138. Well, 1300. One, two, three, 4,000, whatever. So in here, if x equals 1300 times 0.124, 138 minus that answer equals b equals negative 23.2, which means y equals 0.124x minus 23.2. So that'll be, continue with x? Yeah, I think so. Let's see if I'm able to do it this way. To 1800, and then the new equation is going to be that 0.24 times x minus 3.2. Relatively quick. Let's maintain the 5, although let's just maintain the 5. 1800 x equals, what was the next one? 29. And then what's that equation? Y equals, well, if y equals 200 and negative 0.09091, it's repeated here, but I'm rounding up, times the 1800x3 plus b. What is b? B equals times negative 0.09. Whatever, I'll just do that. Plus 200, 36 point, I can't have it, 36.36, repeating. Okay. And so y equals minus 0.09091 x plus 36.36, repeating. Okay, so here's what we'll do for that. 36.36 minus 0.09091 times x. This next one is from 2900 to 3150. So if y equals 100 equals 0.128 x plus b, where x equals 2900. So 0.128 times 2900 equals that. 100 minus that answer equals b equals minus 271.2. Y equals 0.128 x minus 271.2. 913. 0.128 times x minus 271.2. And then there's one more. Okay, and then this is going to be from 3150 to, what's the number? 4,000. If y equals 132 equals minus 0.10824 times 3150 plus b equals b equals 472.956. Let's just keep that. So what's the final equation? Y equals minus 0.10824 plus 472.956. Okay. Brightness equals 427.956 minus 0.10824 times x. This should be in parentheses, and this should be in parentheses. Okay. So let's see what happens there. Expected, comma, this, oh, is it that? Okay, let's see how this LED holds up. It should decrease, increase a little bit, decrease. Okay, that goes by really quick. So I might as well just do 1. And then I wonder what this would do. What is this, 4,000 seconds? $4,000. said it in the previous. Adjust delay for speed of dimming. For speed of dimming. So 5, I guess, is slow. So what if I did that to 50? Let's see, the ones with 2900 to 3150, that one, let's take a while to dim that one. 1300 to 1800, doesn't need to take too long. Let's do 100. I just want to see the LED dim. I don't know, I'm not noticing a change. Maybe. I wonder if it was also because of this. Let's put that to 1K. See what happens. Yeah, I'm not noticing any sort of change. Okay, then let's go back to 5. And I'm thinking it's this. But if it increases at 10, this isn't necessarily time. This is time. I guess we do want this to go by quickly, right? We want to see dramatic shifts. But we want to see dramatic shifts over time. So what's a good, what, 25? Not 50. Let's do x plus 50 each time, but let's do this over a dimming factor of 50. Okay. I think I'm understanding it. Okay. So now we want this to be, let's, 25. 25 increments relatively quickly. One, 2, 5. Let's take a while with this. 75. Gonna take a while. 29 to 3150. This one's gonna go up pretty quick. 10. And we're gonna delay it. Let's say 50. That's a safe number. Let's say this one's 50 as well. But this is over 75. Okay, let's see what that does. Okay, so it does something. How about instead of 1,000, we say 5? Oh, that makes it go much faster. So let's say it's at 50, 5,000. So that second decrease, that went by pretty quick. We want it to be a bit slower than that. Well, no, this would make it go slower. Let's do 75. Let's see what it looks like, but I'm pretty sure I need to go to 75. Yeah, that was a bit quick. Um, let's double that. Let's quadruple it. 75 times 4, 350. How would that have worked? 300s, bro. Come on. Okay, so let's multiply by 4. Let's take a while to do some of these. Because that delay of just quarter millisecond is not a lot. 320. I don't know what this does. For some reason, it just snaps to 1 in one of those equations. Theoretically, if we were to have a 2900, the brightness next to 2900, that should equal the brightness when it's at 2900, technically. So let's see, 2900 times 0.1. That's what we have. 7 plus 36.36, 36. Can't be it. 2900 times 0.0091. 263. Okay, repeating. So then minus 36 sounds negative 1 plus 36.36, blah, blah, equals about 227.3. 227, I'm not going to remember that. That would be a negative value for the 0.128, 124, 128.9091 is negative. Okay, wrong. So this was 2900. Technically, 2900 should start there. 29 times 0.128 minus 271.2 equals 100. That one does equal 100. Wait, so in that previous one, 100 minus 36 divided by negative 0.909. Let's just x has to equal minus 70. Ah, damn. Divided by 10 or times 10 minus 700. Is my math wrong? It seems. 1800 times 0.90909090. I'm sorry, 0.09090999. Sure. Oh, is it 200? Yes, it is 200. It equals 36.36. is a negative value. Y equals 36.36 repeating minus 0.09. I do have 0.09 in there. For just to test it out, what happens if x equals 1800 on the upper side? Times -1 plus 36.36 equals minus 127. How? That doesn't make any sense. Oh, does M shouldn't change. 200 minus 138 divided by 0.5. Oh, it's not 0.5 divided by 1,000 because it got moved over by 1,000. 0.124. What about this one? Divided by 2,900 minus 1,800. Oh, no. Me doing that shouldn't have changed anything. And yet this equation is weird. Is it just that one? Okay, 1,300 times 0.124 minus 23.3, 137.9. Close enough, 138. Okay. Close enough, 138. So then what if the upper limit? 124 times 1,800 minus 32.2, 191. It's saying that the value would be 191 if x equals 2,900. How, what am I missing? Y2, 138 minus y1, 255, over x2, 1,300 seconds minus 0. Same thing there, 200, 138, 1,800, 1,300. Okay, let's go from the very top then. 13, if x equals 0, if x equals 13, sorry, if x equals 1,300 times negative 0.09 plus 255 equals 138, the first bump. Okay, so for the first one, 1,300 times 0.124 minus 23.2. That one is 138. So theoretically, if I were to put the next number in, it should go up to 200. 1,800 times 0.124 minus 23.2. That is 200. Okay. So then if we put 1,800 minus 2, negative 0.0909090909, so on, plus 36.3636363636. Okay, so something's wrong there. So let's label this M1, M2 was correct. Is this going to be M3? 100 minus 200 divided by 2900 minus 1800. 0.090901. If x equals 1800, y equals 200, 1800 times negative 0.090909, repeating. Okay. And then you add it to both sides. That's, wait, minus 200. This goes to 200 equals minus 163.63 repeating plus b. Yeah, so you add it. Okay, but I was messing up in my head. Okay, so that's y. So that's what the equation is. Y equals 363.63 repeating minus 0.0909 repeating. Okay. So now where are we in this equation? .63 repeating. Let's yep. Okay, let's try again. Because I expanded the time that it takes to do this. Especially for the really bright part in the beginning. Okay, then maybe what I should do is make it, but if I make it steep, I'm gonna have to change the equation. I'm gonna have to change the first two. Finally, okay. Yeah, it's kind of slow. So let's make the first one back to 50 since we want to hurry down the brightness. 1300 to 1800 has an increase. So let's hurry through that as well. But then the next one has a pretty, let's just do it half as much. And the decrease, let's make that 150. 29 to 31, this is 29 to 31 is going to go up. So let's make that relatively quick. Let me do 100. And then this one, the problem is that okay, so we need to do two parts. One, we need to decrease the rate that it moves. But two, we would want to increase or So how long would it take? 850 divided by 50, 85 divided by 5. What is that? 17. 17 times 0.2, 3.4 seconds. I don't mind waiting to see that in 2 seconds. 2,000 divided by 17. So let's say 120. So 120, about, okay, just a bit more than 2 seconds. Okay, let's see what that does to this. There was one that did take a while. I think it's the fact that it's in 5 increments. So let's speed that up. Let's say 75. No, it's 75, and let's say this is 10. Okay. Unfortunately, it wouldn't be so simple as to just take the inverse. We also need to know what the b-intercepts are. I could have done this a different way too. I could have just said each one starts at x equals 0, but make the span the difference between them. So this could have been 0, it could have been 500. Would that have made the equation easier? Well, yeah, because then x would have been 0, and y would have just been equal to whatever the y. This would have been 500. No, it wouldn't have been 500, but it would have been, I don't know if it'd be easier. Okay, well, anyway. X equals, since we did this is at 4,000. We want to go up to 8,000. That goes by way to do. So that's half as much. Half 50, 20, 850 divided by 20, 85 divided by 2, 4.2 seconds. No, 8.2 times 60. That's still 4.8. No, 4.2 times 60. That'll be 2. Let's do 30. Fine, you got me. It's a much smoother transition. What happens if I would have done in 1? If x plus 1, then we would have to make that 850 points. If we want to decrease 850 points, 850 points at 1 millisecond each is about 0.85 seconds. And what if we did 2 plus 1? What does that do? It should make it more smoother, right? A bit, yeah. Okay, so 7.5 is that. If this is 250 delays, 250 delays times 7.5 milliseconds, so 1.875. Well, what if I only want it to be over the course of half a second? What was the equation? 250 times 7.5. So if I want half a second, 2. So if this is over 1,100, if this were 1, that would be 1.1 seconds to get through all of these. Do I mind that? .1 seconds to go from 363. 1.1 seconds to go from, which one is that? To 0.9. From 200. X equals 1.8, 200 to there. 1 seconds to reach that. Right now we have half a second to get up here. And then 850 times 2, 1.65 seconds, 1.7 seconds to get from there to here. Half, 1.7. All right, let's just take a look at what that actually means. Okay, this one was a bit quick, 1100. Let's make that 2 seconds as well. Kind of want to make that steeper. So hold on, equals 100. What if we wanted it to go steeper? Well, then we would need this other slope to be different. With the slope, can't change that without changing the second one. All we can change is the amount of time it takes. So what, do we want it to be quick or slow? If I make this 1, it will take 1.1 seconds. If I make it 2, it'll take 2.2 seconds. I think I want it to be quick. Okay. 1800. 1. Let's see. So 500 times 1 would mean it takes half a second. Times 2, which means 1 second. I'm fine with half a second. 0 to 1300 means 1.3 seconds. I wonder if I'd be able to do decimal numbers for this. I'd be curious to know what a 0.5 would do. I'm curious if I can. I can. Nice. One, two, three, four. For some reason, there's a jump at 4. 18. Let's say this equals 2900. Times -1 plus 3.63636363636, and so on. Equals 100. And that's to be expected. It should equal 100 when that equals 2900. But for some reason, there's a jump. Let's see if I can notice it on the screen. Right there. That jump. That was... It was somewhere here. I don't understand. Shouldn't this one be 100 as well? Yeah. Maybe it's... Okay, 8:30. I guess we can't get through quadratics today. No matter. There's always tomorrow. So now since we have up to x6, we're going to need the same on the other side. 1, 2, 3, 4, 5. X7, 8, 9, 10, 11, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. And this is going to be y7, 8, 9, 10, 11. So by going in reverse, the y value should be the same. 132, 100, 200, 138, 255. But the x values, so if this was 850, 4 plus 850, 4850. Distance from here to there was another 250, 5100. Distance from there to there was 1100, 62. Distance from there to there was 500, 67. And the last one goes up to 8,000. Okay. Because plus the 1300. Okay, so now we have the new numbers. X6, Y6 is 4K 240. So once again, Y2 minus Y1, 132 minus 40, 82 over 850, M6, or is this one M6? 1, 2, 3, 4, technically 5, 6. Point 0.9647 minus 32 over 250. Oops. Seven equals minus 0.128. Is that just, this one is weird. 40 minus 132 divided by 850. 0.10824. Huh. That's really interesting. 40 minus 132. Oh, that's because my number's off. 92. 132 minus 40. Yep, 850. Okay. 0.10823. So these are all going to be the other way. So M8 equals, this one's positive. This is the period 0.1. Positive, negative, positive. 0.09 repeating. Negative 0.124. Positive 0.09. And if y equals mx plus b, if y equals 40, m equals 0.1082, whoops, 3 times the x of 4k, b is going to be, I should have used an Excel sheet. Excel sheet would have made this easier. Oh well. 4,123 times 0.123. 40 minus that answer equals minus 392.92. Let's see if y equals 132 equals minus 0.128, 4850 plus b equals 132 minus that answer. 752.8. I should rewrite this. Y equals 0.10823 minus 392.92. Y equals minus 0.128 plus 752.8. Ooh, I'm running out of real estate. Y, if y equals 100.09 repeating times 5100 plus b equals 100 minus that answer equals minus 3.636. That's suspicious. Hold on. Minus 3. $255,392. It's weird that this one is minus 36. Where were they? Yeah, because this one here was positive 363.63, but this one's going to be negative. That's an interesting thing. So y equals 0.09 repeating minus 363.63 repeating. 200 equals 0.124 times 6200 plus b 6200 times 0.124, 200 minus the answer, b equals minus 568.8, y equals 0.124 x minus 568.8. Last one, 138 equals 0.09 6700 plus b equals 138 divided by, nope, minus 0.09 times 6700 minus 465, y equals 0.09 x minus 465, and that does not compare. All right, that one's weird. That middle one is like really cool but really weird. This one down. Okay, well, I guess if they're gonna meet at a point, it would be okay. Still, you would think, well, I guess these do meet at a point. The point would be the 4000 x6. And if these two were to meet at a point, it'd be somewhere really, really low. A lot lower than that. All right. Anyway, moving on. So we have our new equations. 6, 7, 8, 9, 10. So that would just be a matter of, let's see, doing all of that again. So 4,000, 4850. First equation, that one should have an x. 0.10823 times x minus 392.92. Let's keep that like that for now. To 51. So 52.8 minus 0.128 times x to 6200. 4850, 4850 to 51, 51 to 62. Okay, I'm gonna need another one. For 62 to 67. Yeah, okay. 51 to 62 is the 8's, y equals 0.09 times, what is that? X minus 363.63 repeating. 700 0.124 times x minus 568.8. That is suspicious. Why is this also? This should be negative. Why would it be? Oh, because if this is negative, then 200 minus the negative. Dang it. 0.124 times this 200 times negative 1. 200 minus the answer. It's a positive 9. Positive 968.8. Plus 968.8. This is negative. And then, and one more. Copy. 62, 67, 80. Zero, nope. 109 times x minus 465. Right. You know, I think it's that 5,000 thing. I think I should just delete this. And that does that weird stuff. Okay, hold on. 0.5, 1, 1, 2, 2. 0.5, 1, 1, 2, 2. So this should go down the other way. 2, 2, 1, 1.5. Actually, no. 4, yeah, because it goes down, goes up. Okay, yeah. Now it should be symmetrical after the 4-second mark. The supposed 4 seconds. Wow. It really just goes straight up. Why would it do that? $392.92 minus, so as it increases, theoretically the distance should increase. Let's see, what is 4123 times 0.10823 minus 392.92. 40. That equals 40 for brightness, which is to be expected. Oh, you know what? And then at the very end, what we're gonna have to do is say x equals 0. So that way it sufficiently resets. What? X was not declared in the scope. You said int X. Okay. Int X equals 0. Now what? Still that weird flash there. There. And then a second one. 0.5. Well, delay. Okay, what if I just let it go as intended? 1, 1, 1. 1, 1. 1, 1, 1. 3, 4, 5, 6, 7, 8. We start. But there's still that transition. For some reason, it just skyrockets. We're at 4,048. So what's 4850? Oh, is it 0.01? 0.10823, 4850. Four, 1, 2, 3 times 0.10823. 4D minus the answer equals. Okay. So what happens if x equals 4D850 times 0.10823 minus 392.92? That should equal 132. Pretty close. What about this next one? 758.2 minus 0.128 times x. What value is that at? 4850 times 0.128 times -1 plus 752.8. That should also equal 132. Yeah, and yet it does a weird jump there. 5100 times -0.128 plus 752.8. That goes to 100. I'm not restarting the code anywhere. Int x equals 0. Is that causing a problem? So 4 to 4850. It's just a weird transition somehow. Bright, dim, and then, you know what? Then let's multiply that over 5. Let's let that take a little longer to. No, let's take it even longer. Half a second for each step. Okay, so there is something going on. Then what about this step? Let's say Man, I wish I could put an if statement here, but it's about time I get off here. I don't like what's going on here. Can we change that to just like 3950? I'm not sure what that'll do, but dim, bright, dim, slowly dim. Okay, and let me change that back to 1. Okay. See, that did it. But there's that weird step. Where would it be? Honestly, I think it's just a matter that it goes by a bit quick. Let's double all of the delays. You know what? Pin mode int a. So, you know what? Int a equals 2. And then if we set the delays to equal to a, goodness, has to be so specific here. A. Okay, let's see what happens there. Okay, I think I can just put it in here then. Int a equals 2. Delete that. If it doesn't go there, then I think it goes outside everything. No, okay, so that wouldn't do. Still, it has these weird jumping moments. You know what? Let's do it this way. How am I gonna do it? What do I assume that it stays at brightness whatever for a certain amount of time? That would be a lot of additional work. And as I said, it's 9 o'clock. So that's the end. I'll be back on Saturday. Goodness, I'm going to be going on my trip. Yeah, I guess I'll be back on Monday then. Okay. Okay, I guess I already need to work on the quadratic equations then. Maybe, well, this was a good one. Difficult, but not horrible. Okay, so we're going to save that. Okay, we're going to end the stream then.